This video will go over 8.6 and 11.8. So with 8.6, the idea is if you have two similar figures and let's say the ratio of lengths is A to B, then the ratio of the areas is going to be A squared to B squared. And then in 11.8, the ratio of the volume is A cubed to B cubed. Right? And that's in 11.8. So for example, here, if you need 3 ounces of shredded cheese to cover a 12-inch diameter pizza, how much shredded cheese would you need to cover a 16-inch diameter pizza? Well, in terms of 3 ounces, that has to do with area because you're covering an area, right? So 3 ounces will cover a certain area of the pizza, whereas 12 inches is a length. And if you have, let's just draw a picture here. So a medium pizza has a 12-inch diameter, and a large pizza has a 16-inch diameter. So the ratio of the side lengths, ratio of the lengths, I'm going to write that, ratio of the lengths is going to be 12 to 16, which is 6 to 8, which is 3 to 4. I like to write it as small as possible. So 3 to 4. So what's the ratio of the areas? It's the ratio of the areas. Well, that's going to be 3 squared to 4 squared, like we saw above. So that's 9 to 16. Okay, so if I have 3 ounces of cheese to cover the medium, well, how many ounces will I need to cover the large? Well, that's going to involve setting up a proportion. And the 3 will go on top because it corresponds to the 9, the smaller area, 9, and then x will go on the bottom. And you'll just cross multiply and solve. So 9x will equal 3 times 16, which is 48. And then you'll go ahead and divide 48 by 9. X will be 48 divided by 9, which is equal to 5 1/3 ounces. So to summarize, you have 2 pizzas. One is a 12-inch and a 16-inch. So the ratios of those diameters are a ratio of lengths. 12 to 16 would simplify us down to 3 to 4. And then that means the ratio of the areas is 9 to 16, right? So if the area of the medium pizza is 9, the area of the large pizza would be 16. Or if the area of the medium pizza was, say, 18, then the area of the large pizza would be 32. You just double it. But it turns out you need 3 ounces, right? So 3 ounces. You get 9 divided by 3, right? So you'd also divide this by 3. You get 16 over 3. And that's 5 1/3. So it's all ratios, all proportions. Okay. Let's do another one here. If the area of triangle BCD and the area of triangle XYZ have a ratio of 4 to 1, that means the ratio of lengths is what? Well, it'd be 2 to 1, right? Because the areas is 2 squared to 1 squared, which is 4 to 1. And so we know the area, if it's 2 squared to 1 squared, the ratio of the lengths would be 2 to 1. So that means that xz will equal 11 because 22 to 11 is a ratio of 2 to 1. And we have inches as units. Okay. Another problem. The ratio of the areas of 2 similar trapezoids is 1 to 9. So the ratio of the lengths, well, let's see here. The ratio of the areas is 1 squared to 3 squared. That's 1 to 9. And so the ratio of the lengths would be 1 to 3. Or the ratio of the altitudes, 1 to 3. Okay. So what I'm going to do now is go right to the area and similarity problems. And I had you guys doing 1 through 5. Or actually it was 1 through 7, I believe. Okay. So for number 1, your answer should be 5.4 centimeters. And you're going to get that by setting up a ratio of the areas, which is just the ratio of the side length squared. And the area of the large one is 15. You need to find the area of the small one. So that's 25 over 9 equals 15 over x. And then you're just going to cross multiply. And when you solve for x, you should get 5.4. You're just going to put units on the end of that. So ratio of the areas of two circles is 4 to 9. And so think of that as 2 squared over 3 squared. And so the ratio of the radius or the length is going to be 2 to 3, right? So if you have a to 6, what would a be? Well, a would be 4 to have that same ratio. It would be 4. You could also set up a proportion. You could say 2 over 3 equals a over 6, and then cross multiply, and you would get 4. For this one, you're just going to, let's see here. So squaw is 3 to 5, but you're going to square these. So 9 to 25. And this one will be 6 squared to 1 squared, which is 36 to 1. This one will be 100 to 16, because that comes from 10 squared to 4 squared. Right? And number 4, how did I get 6 to 1? Well, the circumference is 12 pi and 2 pi, right? I know circumference is 2 pi r. So the radius is 6 for this one, and the radius is 1 for that one. So the ratio of the radii is 6 to 1. Now you could just go 12 pi divided by 2 pi, and you would still get 12 to 2 or 6 to 1 as well. All right. The ratio of the corresponding midsegments of two similar trapezoids is 4 to 5. The ratio of the areas would be 4 squared to 5 squared, or 16 to 25. And if the ratio of the areas is 4 to 9, so 4 to 9 is 2 squared to 3 squared, or 2 to 3. It's going to be your answer there. All right, so in summary, what I expect you to know for the final is that the ratio of the areas is scale factor squared, or the ratio of two sides or two altitudes of two figures squared. And so that's what you'll see. The next thing is 11.8, and I'm just going to do this extra example here. So if the ratio of volumes is 64 to 27, then what's the ratio of the areas? Well, volume, again, is the scale factor cubed. Oops, hold on. Right, so if you have A to B, that's lengths, areas, volume. Okay. So A to B, A squared to B squared. So we know that the volume is 64 to 27. And that's going to be 4 cubed to 3 cubed. So area would be 4 squared to 3 squared, and lengths would be 4 to 3. And this can be simplified as 16 to 9. So this is area, and this is sides. Those are your two answers there. Okay, let's go ahead and do some volume. I believe I had you do 2, 3, and 5 for this one. All right, so with 2, we need to decide, are these similar? And if they are, then 8 over 2 would equal 6 over 1.5. Does 4 equal 4? It does. So yes, the answer would be yes. Oh, wait, hold on. I'm going too fast. Yeah, way too fast. Do you see what I did? 8 is this side, corresponds to this side right here, right? So it was correct to go 6 over 1.5, but I need to find this length in order to compare it to the other one. Well, this is a 6, 8, 10 right triangle, right? So the question is, does this equal 10 over 2? The answer is no. 4 does not equal 5. So this is not similar. There we go. With number 3, triangular prisms are similar and the ratio of A to B is 5 to 2. Find the volume of the large prism is equal to 250 centimeters cubed. What's the volume of the smaller prism? Okay, so the ratio of side lengths is A to B, right? So that means the ratio of the areas is A squared to B squared, and the ratio of the volumes is A cubed to B cubed. So we're given the volume of the large is 250 centimeters cubed. So what's the ratio of the volumes going to be? Well, it's going to be 5 cubed to 2 cubed, which is 125 to 8. And so then we'll just set up a proportion, or actually, we don't even really need to, do we? Because if you go 125 to 8 and the area is 250, looks like you're just multiplying that by 2. Still be 250 to 16. So it'd be 16 centimeters cubed. Okay, so to review, you need to know that the ratio of the scale factors is the ratio of areas is a scale factor squared, and the ratio of volume is scale factor cubed. All right, so that is the notes and homework for 8.6 and 11.8.